Hello, today we're going to be talking about lesson 6.1, which is on angles of polygons. A diagonal of a polygon is a segment that connects any two non-consecutive vertices. So if you see right here, P to S, those are non-consecutive because they're not right next to each other. Where like P to T or S to T are consecutive, they're right next to each other. So these diagonals help us because what they do is they form triangles in our polygons. So obviously in a triangle, there's one triangle. In a quadrilateral, there's one diagonal, so two triangles are formed. In a pentagon, there are two diagonals, so one, two, three triangles are formed. And essentially this pattern continues. So if you look at this pattern in the table below, triangle has one triangle in it. A quadrilateral has two. A pentagon has three. A hexagon has four. And so you'll see it's actually the number of sides minus two. And so this actually helps us come up with theorem 6.1, which is the polygon interior angle sum. So what it says is you take the total number of sides in a polygon, subtract 2 from it, and then you can multiply that by 180 because there's 180 degrees in a triangle to figure out the total number of degrees in our polygon. So let's look at an example. It says find the sum of the measurement of the interior angles of a convex heptagon. Okay, so right here over on the left, okay, it shows all the different types of polygons that have, or common types that have names that you should probably somewhat remember. If you can't, that's okay. We have resources, you can look them up. But a heptagon is seven sides. So my number of sides is 7. So I go back to theorem 6.1, the interior angle theorem, and I say, okay, so 7 minus 2 times 180. Well, 7 minus 2, easy, is 5 times 180. So I multiply 5 times 180, and that's 900 degrees. So just like you said, a triangle has 180 degrees in all of its angles, a heptagon has 900. Letter B. Find the measure of each interior angle of this quadrilateral. So you'll see B, it's not a very good picture, but B is a 90-degree angle, it's a right angle. So is letter C. Okay? And we know that A is 3x, and we know that D is just x. Well, how much does it have to add up to in a quadrilateral? Well, let's see. I have 4 sides, n equals 4. So I do 4 minus 2 times 180. 4 minus 2 is 2 times 180. Easy math says that's 360 degrees. So all of these added up should add up to 360 degrees. So I say 3x plus x plus 90 plus 90, I'll add that together as 180, should add up to 360 degrees. Combining our like terms, we'd say 4x plus 180 equals 360. Subtract 180 from both sides, and you find that 4x is equal to 180. Divide both sides by 4, and you see that x has a measure of 45. Okay? So that means that this x right here is 45 degrees, and this measure right here, 3 times 45, would be 135 degrees. And if you wanted to check your answer, you could add up all 4 of them. It will add up to 360 degrees. Here's a problem for you to do. A couple questions are coming up. Now, we can use this in a word problem. It says the poles for a tent form the vertices of a regular hexagon. When the poles are properly positioned, what is the measure of the angle formed by the corner of the tent? So, it says right here, hexagon. Hexagon is how many sides? If you don't know, you can look it up. Hexagon is 6 sides. So, my n is 6 sides. So I do 6 minus 2 times 180. Well, 6 minus 2 is 4. times 180. 4 times 180 is going to be 720 degrees. So the total of all of my angles is 720 degrees. And I said, okay, well, if it has 6 sides, it means it also has 6 angles. So I take the 720 divided by 6, and I find that each angle is going to add up to 120 degrees. Here's a guided practice problem. Letter A says, find the measure of each interior angle of the regular hendecagon that appears on the face of the Susan B. Anthony $1 coin. So hendecagon obviously is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 sides. So you say n is equal to 11. That'll help you with the next question. All right. So we've looked at it when they give us the number of sides in our polygon, and we have to find the angles. So let's see if we can do the opposite. The measure of an interior angle of a regular polygon is 135 degrees. Find the measure of the sides, or find the number of sides of the polygon. So that means each angle is 135. It's regular, which means all of the angles are the same. So that helps us out quite a bit. So 135 times the number of sides should be equal to that theorem that we started with, 6-1, which is n minus 2 times 180. So essentially what I've done is set up this problem. The number of, or the angles times the number of sides, all of that should add up to the same as the total angle measure in the polygon. So I have to distribute. I get 135n is equal to 180n minus 360. Now it's a moron problem. Well, the nice thing is that there's only n's on the left, so I'm going to subtract 180n from both sides. And I get negative 45n is equal to negative 360. I divide both sides by negative 45, and I find that n is equal to 8. So, what does that mean? It means that this right here, the number of sides, is 8, which we know is to be an octagon, 8 sides. Here's a guided practice problem. This time they tell us that each angle is 144 degrees. You find the number of sides. Last thing we have to talk about is now exterior angles. Now we've talked about exterior angles before in triangles. It's the number on the outside of an angle. So all of these right here had to add up to 180 in a triangle. And actually you'll see that all three of the outside numbers then add up to 360. Now we have a quadrilateral. All of my angles right here add up to 360. And all my outside angles add up to 360 again. Now I have a pentagon. 1, 2, 3, 4, 5 sides. Okay, that adds up. 5 minus 3 is, or excuse me, 5 minus 2 is 3. 3 times 180 is going to be 540. All those add up to 540 inside. Then all the outside numbers add up to 360. Interesting, they all add up to the same number on the outside. And that actually gives us theorem 6-2, which says that the sum of the exterior angle measures of a convex polygon, meaning it doesn't cave in on itself, one angle in each vertex, is 360 degrees. They always add up to 360. So let's look at this problem right here. It says find the number or the value of x in this diagram. Okay, so I have all of these exterior angles. And we just said in the last theorem 6-2 that all of those have to add up to 360 degrees. So I do 2x minus 5 plus 3x plus 10 plus 6x minus 5 plus 2x plus 5x. And all of those are going to add up to 360. Let's combine our like terms at this point. 2x and 3x is 5x, plus another 6 is 11x, plus another 2 is 13, plus plus another 5 is 18x. And then let's combine our other like terms. Minus 5 plus 10 minus 5. So minus 5 plus 10 is a positive 5, minus 5 is 0. So it's actually nothing left, it's just 18x is equal to 360 degrees. Divide both sides by 18, and I find that my x is equal to 20. So notice they just wanted the value of x, so I am done. They could have asked for each angle measure, and then what you do is you put x in, 20 in for x in all of those. But they didn't ask for that this time. Letter B. Find the measure of each exterior angle of a regular nonagon. So we need to know what a nonagon is again. So if we look back, or you look it up, nonagon, 9 sides. Okay? So this is 9-sided figure. So essentially, what we have to do is we say, okay, well, we have a regular nonagon, which means all of the angles are the exact same. Okay? And it means that their exterior angles are also going to be all the same. So 9 times the number of angles, or excuse me, the measure of each angle, has to add up to 360 degrees, since all of them are the same. Divide both sides by 9, and I find that n is equal to 40 degrees. So what's the measure of each exterior angle? It's 40 degrees. So we can do both where we find the value of x for those measures and also what they are in a regular polygon. Here's your guided practice problems right here. They both will help you to continue on with the lesson.